Hello and welcome back to the lab. So today we're going to continue work on the restoration of the Packard Pla-Mor Jukebox amplifier. So let's get started. But before I get involved in the electronics of today's video, I wanted to show you this that I'm really excited about. These are two nameplate, serial number, model number tags that were on the chassis of the amplifier originally. This one has the manufacturer model number, serial number, some power supply information, volts, cycles, watts, etc., etc. Has some minor scuffs on it, and it's basically usable, but it's a little bit scratched up and dinged up. This one was on the top of the chassis, and this is made of brass, and it goes around the bass and treble controls, and it's basically unusable. It's full of corrosion, and you can't read it, and it's just horrible shape. I wanted to see about getting reproduction serial number tags. These tags made for the unit, and I don't have the expertise to do this. I don't have the ability to make reproduction serial number tags, but I follow Keith Rucker's YouTube channel, and he works on vintage machining equipment, old lathes and stuff like that he does restorations on, and he occasionally has a need to do nameplates and things on his restorations. And so he uses a guy that he calls his friend Tom Utley from Vaughn Industrial. And so I got in touch with Tom and asked him if he could make reproductions of these tags for me. And he said he would be glad to do that. He sent me a quote. I approved the quote, and I sent him the originals, and he made the reproductions, and they just came back today. So let me show you what we have. I'm going to move these over to the side. So these are the reproduction tags that he has manufactured to replace the two originals. This one is made of brass. This one's made of aluminum. It has the model and serial number stamped in there. I guess they're all laser engraved and laser cut and etched out with some sort of process. You know, actually, Keith Rucker has a video of the entire process that Tom does when making these replacement tags. And I'll put a link to Keith Rucker's video in the description of this video. But these are absolutely gorgeous. He also made me an aluminum one of the same one as the brass one here. He made an aluminum to match as well. I won't be using the aluminum one. So if anyone else is working on this same amplifier and wants me to send them this reproduction tag, I can do that. I'll send it to you for free. Just send me an email. I'll keep my email address in the description of this video as well. Now, these are just beautiful. A whole lot better than what was on there originally. They weren't cheap. They were rather expensive because they're a one-off, and it took some time to actually scan in the originals and clean up the artwork and make the masking. And I don't really know the whole process, but it's a very involved process. It took several hours. It actually took several weeks worth of time to get them done. But they just arrived today, and I can't wait to install them on the chassis of my amplifier. So if you have someone that if you have a need for this type of work, contact Tom Utley at Vaughn Industrial. He'll help you right out. He sent me this sticker that you put on your toolbox or whatever, so we'll probably do that as well. All right, let's install these on the chassis of the amplifier. All right, with those name plates mounted, it looks like $1,000,000. That I am so impressed. These are just gorgeous work. Tom Utley at Vaughn Industrial. If you have some work like this that you need, go to him. He'll do an excellent job for you. All right, so with those nameplates installed, the cosmetic restoration of this amplifier is basically complete. But we have a lot of electrical work to do still underneath. That's why we still have the wooden frame on the outside here. So let's get to work on some of that. Okay, so we're looking at the underside of the chassis now. I've decided to basically replace almost every component inside the chassis on the underneath side. I've replaced the bass control and the volume control because those were both defective and not easily repairable. In fact, I decided it was just not worth the time and effort to try to repair them. They were defective, and I just replaced them both with these little cheap pots that I got from the mail order electronic parts place. The treble control is still the original control. I did spray it with a little bit of contact cleaner to clean it up, and that is the original control. I've wired up all the capacitors that go with the bass and treble tone controls. I replaced those wax capacitors with these new poly caps. I'm still using the original 500 picofarad mica cap that's here. I actually tested it and measured it, and it measures 455 picofarad, which is close enough, I think. And it's in good shape, so I'm just going to reuse that mica cap. All of those paper wax capacitors, I'm going to replace them. These over here, I have replacements for all of them, and what I'm going to do is, as I remove them, I'll test each one to see if they're actually still good or if they have leakage or are defective in any way, and then I will solder in a new one in its place. I've also decided to replace all the carbon composition resistors, even if they test good, but I will remove them all and measure them one at a time and document which ones I found that were defective. I'm replacing them all with these blue colored metal film 1% resistors. I have lots of them, so I'm just going to use these to replace the carbon compositions. And I'm about maybe a third of the way through that now. I decided to concentrate on the preamp stage, so I've got that mostly wired in place. I'm a little concerned about putting the B plus onto the plate of that tube because my B plus is still measuring very, very high, and I don't want to burn anything out. I've already put a lot of money into replacing all these electrolytic capacitors, and I don't want to damage them by accidentally putting in too much voltage. So what we're going to do is instead of the voice coil instead of the field coil on the field coil speaker, we're going to put in some power resistor to replace that field coil, and we're going to use I measured a 4K resistor would probably work fine. This happens to be a 1K resistor. I don't have a 4K resistor yet. I have one on order, and when that comes in, we're going to solder it onto this terminal strip over here that I've installed to take the place of the voice coil speaker. The other power resistors with the voltage divider circuit are fastened to the side of the chassis over here, and that basically lowers the voltage from 400 volts to about 300 or so to power the preamp stage and the intermediate stage tubes, as well as the screen grids on the output stage tubes. So that output divide, these two resistors test fine, so I'm just going to reuse them. And that voltage divider output over here will be connected to all those, the intermediate stage tubes, the preamp tube, and the screen grids of the finals. The output transformer primary has been wired to to the center tap. The center tap has been wired to the electrolytic bypass cap over here, and the two ends of the primary of the output transformer have been wired up to the plate connections of the output tubes, the 6L6 tubes. The secondary side of the output transformer is wired up for 1, 2, 3, or 4 8-ohm speakers in parallel. And so there's 4 different connections as well as a common in the output secondary side of the output transformer. Those are all wired up into the selector switch to select the number of 8-ohm speakers. That is also wired back into the original field coil speaker connection for the internal Jukebox speaker, which we're not going to be using. So we are going to be using the output terminals over here that are the screw terminals at the top of the chassis, and that is wired up as well. Most of the intermediate stage amplifier and the output stage amplifier has not been wired up yet, with the exception of the filament circuits. They've all been wired. But I want to really concentrate on the preamp section today and finish up that wiring, as well as take a look at some of the components that I pulled out of here and see how they actually measure compared to brand new ones that I'm replacing them with. Okay, so let's take a quick look at the schematic of the part of the circuit that I want to be working on today. This is the 6J5 preamp. It's a single triode, and hopefully by the end of this episode, we'll be able to get this part of the circuit up and running. I hope, anyway. We have an input pot for volume control, 500K audio taper. This one's defective, and I replaced it. Also, there's a 500K in the bass control. It's the same exact pot, and I replaced that one as well because it was also defective and not worth trying to repair. The 50K ohm treble adjustment pot is in fact the original pot. Most of the components in the input circuit, in fact, and in the entire amplifier, have been changed out. Many of them were defective, but I basically changed out everything that I could, even if they tested good. The 4.3K that was originally in the cathode of this circuit, I didn't have a 4.3K resistor, so I replaced it with a 4.7K resistor because I had plenty of those. This resistor actually, coincidentally, did measure 4.7K, even though it was supposed to be 4.3K, because it had drifted up in value over the past 80 years to 4.7K. So I simply just replaced it with a brand new 4.7K. There's a 20 microfarad. This is one of those top-mounted can capacitors. I replaced that as well. I don't even know if that was bad or not, but I replaced all those electrolytic cans. So this is one of the ones that I replaced. The 56K plate resistor was defective, and I replaced it. The 270K resistor here in the B+ line was also defective, and I replaced it. This 15 microfarad capacitor was in fact defective, and this is not one of the top-mounted can capacitors. This is an underneath the chassis point-to-point mounted capacitor. It's a 15 microfarad, 300 volts. I'm replacing it with a 22 microfarad, 350 volt axial leaded capacitor. That capacitor also tested bad. In the output circuit, we have the tone stack, which the treble and bass pots. There's a 0.1 microfarad in the treble circuit. It tested bad, so I replaced it. That's one of those paper wax coated paper capacitors that they always go bad. So I replaced that one as well. 0.05 microfarad, that is also one of those wax-coated paper capacitors. This one actually tested just fine. There was nothing wrong with this capacitor, but just out of general principles, I replaced it with a brand new Mylar 0.047 capacitor, okay? This 500 picofarad was the mica capacitor that was underneath there. It tested good. It actually measured 455 picofarad. I replaced it with the original. I put the original back in the circuit because I don't have any mica capacitors, and there was nothing really wrong with this one, so I just put the old one back in the circuit. I already mentioned that the base control pot was defective, and I replaced it. This 270K load resistor, which is actually the grid leak resistor to the next stage of the 6SN7 stage. This resistor was also defective, and I replaced it as well. In this circuit, you can see a couple of voltages inside of the rectangles. Those voltages are what the service manual says you should measure the DC voltages at these points. Now, interestingly enough, if you do the calculations, they don't seem to all line up. And let me do that now so I can show you what I mean. In this circuit, the cathode current should be the same as the plate current because there's no other current draw through this output circuit, and there should be no grid current flowing as well. So the plate current and the cathode current should be the same. So if we're expecting to have 2.6 volts on the cathode with respect to ground, we can calculate that current. This voltage divided by this resistance, 2.6 volts divided by 4,700 ohms, 550 microamps should be flowing through the cathode. That should also be flowing through the plate, through the tube, okay? So if you do that voltage, we can calculate the voltage drop across these two resistors from the B plus voltage to the plate. So let's do that. 553 microamps times 56K plus 270K. And that is 180 volts. Now let's subtract that from the B plus voltage over here, which should be 285. And you should have 105 volts, basically 105 volts on the plate, even though the circuit, the service manual says that 58 volts should be on the plate. I calculate 105, and to me, although I'm not a tube expert, it seems to me that 105 is a much more reasonable voltage to be appearing on the plate of this 6J5 tube. Although I'm not an expert, the manual actually says it should be 58 volts. I'm not sure if that was correct, or if it's a typo, or if it was a loading effect from the way they measured the voltage with their voltmeter, or who knows why. But I would expect to see much more than 58 volts on the plate of this tube. But we'll get the circuit wired up, and we'll see what actually shows up on that plate. But I'm expecting to see something more like 105 volts here, if we have 2.6 volts on the cathode. So I think I have a few more components to wire up on this input circuit, but it's mostly completed. I don't think this 270K output resistor is here yet. So let's finish those things up. And I wanted to talk a little bit about the concern I had with the B plus voltage. It was measuring way too high, much higher than 285 volts at this point. I don't remember what it was, something like 350 or something. But I did have a solution for that, and let me show you what that is. So this is the power supply circuit that we worked on last week, and the main rectifier tube puts out over here, across these two main filter capacitors, we had measured a voltage of 587 volts at this point right here. That voltage passes, that current passes through the field coil of the field coil speaker, or which should be replaced by a 1K resistor if you're not using a field coil speaker, which we won't be. So originally there is supposed to be a 1K resistor jumpered across these terminals. And that will give you a lower voltage over here, and there's a voltage divider that provides the 285 volts that we looked at on the other schematic. That 285 volts should appear here. We were measuring far more than 285 here, far more than 450 volts here, which is why I didn't want to install this capacitor. The capacitor is mounted physically on the chassis, but it's not wired up into the circuit yet because there was more than 450 volts here, and I didn't want to blow up this capacitor. There's also more than 450 volts here, or close to 450 volts here, so I didn't want to wire this capacitor up. And there was more than 350 volts here, so I didn't want to wire this capacitor up. So I did some experimenting here, and I found that if I replaced this field coil resistor with a 4K instead of a 1K, that I could get these voltages down significantly such that I could wire up these capacitors without fear of damaging them. Now, I haven't done that yet, so I have to do that. When we start drawing more current out of here, of course, these power supply voltages will be loaded down, and I imagine that all of the voltages will come back into spec. But until that happens, we need to use a higher value resistor in the field coil here. So I'm going to use a 4K resistor that seems to drop all these voltages down significantly enough that we can get that preamp circuit going, and we can also install these other filter capacitors without fear of damaging them. So let's finish up the wiring of this power supply and the rest of that preamp circuit, and see if we can't get that thing to work. 2 hours later. Okay, I've completed all the wiring for the circuit we're working on today, and double checked everything, and I think we've got it together without any mistakes. Here we see the 6J5 tube. I've disconnected all the other tubes with the exception of the 6J5 and the rectifier tube, because that's what we're going to be working on, and I don't want to be supplying voltages to any of these other tubes. So I've just removed them to keep them safe, because it's not properly wired yet, and so all kinds of stuff is going on with these other tubes. The 6J5 tube, here's the cathode resistor over here, the 4.7K. We have the plate resistor here, the, the 56K. That 270K that comes from the B plus is here, okay? We have the tone control circuits here, the output that goes to that other 270K load resistor, which is also the grid leak for the following stage, that is here. In the power supply, we have hooked up all of the electrolytic filter capacitors, including this one here, which is the underneath the chassis mounted axial lead filter cap that goes to the preamp stage. Over here, we have the 4K ohm resistor that goes in the field coil replacement line. So that's that power resistor right there. The 2 voltage divider resistors, chassis mounted, are over here. Everything's wired up. So now would be a good time to talk about safety, of course. The kind of voltages we're talking about here: 300 volts, 400 volts, 500 volts, 600 volts maybe. These are lethal voltages. If you don't know how to work on this type of equipment safely, please let someone who does know how to work on it safely do the work for you. You don't want this to be the last amplifier you ever get to work on, okay? These are lethal voltages. You don't get a second chance. If you touch something by mistake, you may not be able to correct that mistake. It'll be too late. All right, So please be careful. Please be careful. All right, let me hook up some voltmeters so we can make sure that nothing is going over voltage. And we'll plug it in and we'll turn it on. Cross my fingers. Okay, so I've hooked up my 3 voltmeters. The upper one reads the voltage at the output of the 4K ohm field coil resistor at the top of the voltage divider. This should probably read something like 400 volts, but it has to be less than 450 volts. The middle one reads the output of the voltage divider. This is the one that we were expecting to be 285 volts, but it has to be less than 450 volts because that's the rating of the capacitor there. This third one is on the underside electrolytic capacitor. That is a 350 volt capacitor. We're expecting this to be something like 200 volts, I think. But it has to be less than 350 because that's the rating of that capacitor. So let's turn it on and hope for the best. I'm a little bit nervous. I don't want to blow anything up. Here goes. It's less than 450, so that's good. It's also less than 450. It's higher than the 285 that we were expecting, but it's less than 450, so that's good. It's safe anyway. It's safe for the amplifier. This voltage, I don't know what it was supposed to be, but it has to be less than 350 volts, and it's far less than 350 volts. 130 seems reasonable, I guess. All right, I think we're in good shape. So what I want to do is I want to measure the voltage on the plate, and I also want to measure the voltage on the cathode. So let's do that now. Let's turn this amp off and see how long it takes for these caps to discharge so that I can stay safe and not get hurt. This one seems to be taking a little longer, but it's discharging just fine. All right, very good. Let me unplug it. I'll move the voltmeters around and I'll plug it back in again. Okay, now the upper voltmeter is connected to the plate of the 6J5 tube, and the lower voltmeter is connected to the cathode of the 6J5 tube. So we're expecting this to be something like plus 2.6 volts. I don't know. And we were expecting this to be something like 105 volts. However, the manual says it's 58 volts. So we'll have to see what this reading is. But I got a feeling it'll be around 105 if this is 2.6. So let's turn it on and see what we get. Wait for the readings to stabilize a little bit. All right, so we have, instead of 2.6 volts, we have 3.5. That's pretty close, I guess. Instead of 58 volts or 105 volts, we have something in between, 88.7. I guess that's pretty good too. I think our preamp section is working. I think it seems like the biasing is pretty close to what we expected anyway. All right, let's apply an input signal and see if we can get an output signal from this amplifier preamp section. I'll be right back. All right, now I thought it was only appropriate, because we're working on a tube amplifier, that I use a tube oscillator to be my signal source. So I got my trusty 200 CD and hooked it up to the input of the amp. And we got the scope hooked up to the input on channel 1 on the upper trace, and the output is on channel 2, the lower trace. Now let's turn the amplifier on and see what we've got. I see basically nothing. Let's give it a second. Oh, volume is turned all the way down on the amplifier front panel. Let me turn it up. Hey, look at that. We do have signal, and it's amplifying as well. We have on the input, I've got 1 kilohertz. That's 10 kilohertz. Let's change it to 1 kilohertz. All right, we have 1 kilohertz coming out of my 200 CD oscillator. That's 2 volts peak to peak, and the output, it's on a 2 volts per division scale, 2, 4, 6, 6.5, something like that. So it's got a gain of not much. Oh, that's 5 volts per division. 5, 10, 15, 16. About 16 volts peak to peak. That's a gain of about 8. 2 volts on the input, 8 volts on the output. Well, that's what it is. 2 volts on the input, 16 volts on the output, peak to peak. That's a gain of 8. Yes, it certainly is. All right, and the volume is turned up all the way. Now we have tone controls. Let's give it a little bit more input, see if we can drive it to clipping. You can go pretty high before we start clipping. Let's see. Yeah, it's clipping now. All right, let's drop it down a little bit. That looks pretty good right there. That's about where we were. That's about the maximum amplitude we got before we start clipping. But it certainly has gain. I wanted to check out the tone controls. The bass control, let's do the treble control first. Let's switch it up to 10 kilohertz. I wonder if it goes to 10 kilohertz. Looks like my 200 CD doesn't go to 10 kilohertz. All right, there's 10 kilohertz. It certainly goes up to 10 kilohertz. Let's dial down the treble control and see if it has an effect. Oh, it certainly does have an effect. It has a very large effect, as a matter of fact. Seems to be distorted down at the bottom end, though. I wonder why that is. I must be driving it too hard. Let me dial it down a little bit. Let's cut it to half of that input. Turn these up. Yeah, that looks a little bit better. It still is a little distorted at the bottom end, but the treble control certainly does drop it down. It's a passive it's a passive treble control, and that means it's only cut the treble. It does not amplify. That doesn't give you additional gain. Only cuts the amplitude, right? Okay, so the treble control is working just fine. Let's go down to maybe 100 hertz. All right, see if the bass control will also cut. Oh, it does. Well, that's interesting. The bass control pot is the one that I replaced, right? And I used an audio taper pot because I used the exact same pot as the volume control. This taper is not the correct taper for this control. I'll have to find one that's a linear taper control. I think linear would probably work better. It seems like the pot has considerable range for about 1/3 of its range, maybe as much as 1/2 of its range, but then it stops really having an additional effect when you turn it down past halfway. All right, so I'm going to have to get a different kind of taper on that bass control potentiometer. Yeah, that's not really, it's not really good. It doesn't spread out throughout the entire range of the control. All right, but it certainly does work. The preamp is working and it's amplifying, and I think everything is coming along just fine. Okay, so that will do it for this episode of the Packard Pla-Mor Jukebox Amplifier Restoration. Thanks very much for watching. Please like and subscribe, and stay tuned for the next installment where we'll continue working on this amplifier. Maybe we'll get the next stage and maybe even the output stage working as well. Stay tuned for that. Thanks again.